Hello class, and welcome to today's algebra lesson, which is about elimination using multiplication. By the end of the lesson, you will be able to use multiplication elimination to solve the system of equations. So when we talked about elimination the first time, we had a pair of matching coefficients that allowed us to eliminate right away. If we look at this one, 6 and 3 and -2 and -7, those do not match. So our first goal is to see if one of the two can multiply to the other. So we would check 3 and 6 and 2 and 7. In this case, 3 can multiply to 6. So what we're going to do is we're going to take this whole second equation and multiply it by a factor of 2. So our first equation is going to stay the same, 6x minus 2y is equal to 10. Our second equation is going to become 6x, so 2 times 3x is 6x, minus 14x from 14y from 2 times -7y is equal to -38, 2 times -19. Now that we have a matching coefficient, we can go ahead and continue our elimination process. In this case, I'm going to subtract because 6 minus 6 is going to eliminate that variable. Then I'm going to do -2 minus 14. When I do minus a negative, that's going to turn into a positive. So -2 plus 14 gives you 12y. And then I'm going to do 10 minus -38. Once again, double negative is going to turn into a positive, which is going to give me 48. I'm going to finish solving that by dividing by 12 on both sides, and I find out that y is equal to 4. Now I need to go ahead and plug that back in to find my x value. So I'm just going to plug it into the first one and go 6x minus 2 times 4 is equal to 10. So I've got 6x minus 8 is equal to 10. Adding 8 to both sides is going to get rid of the subtracting 8 to give me 6x is equal to 18. And dividing by 6 on both sides gives me that x is equal to 3. So my point of intersection for these two lines, if they were put on the graph, is going to be at 3, 4. So our answers are still ordered pairs. We're still looking for where the lines intersect. We just have an extra step of multiplication now. Go ahead and try this one on your own. In this case, you're going to multiply this whole second expression by 3 so that your x coefficients match up. I also multiplied by -3 so that I could add instead of subtract. So that's an option that you have, is always to multiply by a positive or a negative, so you can decide whether you are adding or subtracting. Either way, you're going to end up with a point of intersection at 2, -5. Now we're going to look at 6x plus 2y equals 2 and 4x plus 3y is equal to 8. When I check out my coefficients, 4 can't multiply to 6 and 2 can't multiply to 3. In this case now we're going to have to do a double multiplication. So we're going to want to multiply so that we have to do both of them so that the coefficients match up. The easiest way to do that is just to pick one of the pairs. I'm going to pick 6 and 4. So I'm going to multiply the top equation by 4, and I'm going to multiply the bottom of the bottom equation by 6. So we're just flip-flopping the coefficients. The reason we do that is now when I do 4 times 6, I'm going to end up with that first equation being 24x plus 8y is equal to 8. So I multiplied everything by 4. And on this second equation, I'm just going to show you this time, I could multiply this instead of +6. I'm going to choose a -6 so that I can add my expressions. So -6 times 4x is going to give me -24x. -6 and +3 is going to give me a -18y. And then -6 and +8 is going to give me a -48. So now when I go to eliminate, once again, I am going to eliminate my x's. This time I'm going to do that by addition. 24 plus -24 makes those go away. When I add 8 plus negative 18, I'm going to end up with negative 10y. And when I add 8 plus negative 48, I'm going to end up with negative 40. I can finish solving that by dividing by negative 10 on both sides of my equation, and I find out that y is equal to 4. Once again, I want to plug this back in to find my second variable. You can pick either of the original expressions. I'm going to go ahead and pick the bottom one this time. So I'm going to go 4x plus 3 times 4 is equal to 8. So I end up with 4x plus 12 is equal to 8. Subtracting 12 on both sides to eliminate the adding 12, I've got 4x is equal to negative 4. And when I divide by 4 on both sides, that's going to give me x is equal to negative 1. So my point of intersection for these two lines on a graph would be negative 1, positive 4. So in this case, again, I picked the x coefficients because neither 4 didn't multiply to 6 and 2 didn't multiply to 3. You also could have picked the y's when you were flip-flopping to multiply. Go ahead and try this one on your own. In this case, I multiplied the top equation by a factor of 5, and I multiplied the bottom equation by a factor of negative 4, so that I could add my expressions. Once I did that, I solved for y, plugged it back in, solved for x, and I got a final answer of negative 4, positive 1 as the point of intersection. Last example here, I've got 7x plus 3y equals 14, and 14x plus 6y is equal to 28. As I check, I can use either my x or my y this time, so I'm going to just focus on the x's, and I'm going to multiply by a factor of 2. So when I do that, my top expression is going to become 14x plus 6y is equal to 28. Then when I go through to eliminate my x's, I'm going to subtract all of these. 14x minus 14x gives me nothing. 6x minus 6y gives me nothing. So there's nothing left on the left side. 28 minus 28 is going to give me 0. Because I ended up with a true statement, 0 does equal 0, this would be an example of a system of equations with infinite solutions. So once again, if you get a true statement, 0 equals 0, 10 equals 10, 24 equals 24, whatever it is, this is an infinite solutions problem. Go ahead and try this one on your own. In this case, I multiplied the second expression by a factor of 3 to get 9x minus 15y equals 27. As I subtracted all of these, my x's and my y's canceled out to give me 0. 18 minus 27 gave me negative 9. 0 does not equal negative 9, so this is an example of no solution. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.